Okay, so replace this x with the square root of x minus 5. I'm putting g into f. So when I do that, that's going to look like this. Square root of x minus 5 minus 4 all over 3. Does that make sense?
Yes.
All I did was replace this x with the square root of x minus 5. Okay, so Jade is thinking in terms of domain, because the second question is how do you find the domain of this function? Well, you have to ask yourself the question, do I have any even-numbered roots, or do I have any x's in the denominator? You don't have any x's in your denominator, but you definitely have an even-numbered root. And what's the problem with even-numbered roots?
They can't be negative.
They can never be negative. Why can't they be negative?
She can't multiply a negative times negative and get a negative.
Right, we have to enter the complex number system and put that I thing in there, right? And domain's only for real numbers. So x minus 5 can't come out negative. So if x minus 5 can't come out negative, then what can this x minus 5 be?
0 to infinity.
Okay, but
Any positive number.
so x minus 5 can be any positive number, or it could also be 0, right?
Yeah.
Do you agree, greater than or equal to 0? So if it's greater than or equal to 0, what is,
Just add 5.
and so that means x has to be greater than or equal to 5. Everybody good with that?
Yes.
So if it's greater than or equal to 5, how would you write that in interval notation?
Including the 5 and then to infinity.
Yep. Including the 5 and then to infinity. So 5 to infinity is your domain. Does that make sense to everybody? Okay, you may not have had enough space in here so you could write it down below if you needed to. What's inside the square root can't come out negative, so therefore it's got to be positive or 0. So we say it's x minus 5 is greater than or equal to 0. Move the 5 over, so then that's 5 to infinity. Okay, let's look at the next one. The next one is g composite f, which means you need to put f into g. Take function f, put it into g. So if I take function f and I put it into g, then I'm taking this and I'm putting it right here where the x is. Okay, so if I rewrite that, it's going to look like this. Square root of x minus 4 over 3 minus 5. Does that make sense? Okay, now they're probably going to want you to simplify that. How can I simplify what's inside there?
Multiply by 3.
Yeah, you're probably going to have to find a common denominator and put them together and make them one fraction. Okay, so if you have a 5 over 1 and a x minus 4 over 3, what's your common denominator?
3.
3. So if I rewrite those so that they both have a 3 on the bottom, that's going to be x minus 4 over 3. How can you change a 5 over 1 to a something over 3?
Multiply by 3.
Yeah, 1 times 3 is 3, so 5 times 3 is 15. Or you can just think, hey, what number divided by 3 gives me 5? So now we can rewrite that as the square root of x, minus 19 over 3? Because now that I have a common denominator, I can actually put these two like terms together, the negative 4 and the negative 15. Okay, well, now I have to worry about domain. And domain, do I have any x's in my denominator?
No.
Nope. Do I have any even-numbered roots?
No. So it's good try.
Isn't that an even-numbered root?
Yeah.
Yep, I got an even-numbered root.
I see.
Yes.
So backing up a little bit,
Yep.
why couldn't you multiply it by 3 to get rid of the 3 and then make it 5 or 15?
Because, hang on. You don't have an equal sign in here for one thing, so you can't change the value. So I could have done this. I can't just take this times 3 because that changes the value, right?
Yeah, that would give you 3x.
So I can't just add in a times 3. Now I can do a 3 over 3, but then that doesn't really help me either, right? 3 over 3 is equal to 1. So I can do that when I have an equation. I could take everything times a3, but I don't have an equation. I have an equal sign. Okay? So I had to keep that fraction in there. Okay, so I need to worry about what will make this thing come out negative. Do I need to worry about the denominator at all?
Yes.
Really? There's no x's down there.
Oh,
So I can kind of ignore that, right?
I thought you meant
So what is my my x minus 19 has to come out to be a positive number. X minus 19's, yeah. So x is going to be greater than or equal to 19 if I move the 19 over. So that means my domain is anything from 19 over. Everybody okay with that? All right, moving on to the next page. The last type of question. Okay, so on this type, let me scroll up a little bit there. All right, so they're telling you that, you look at this thing right here, G composite H is equal to this. Okay? That's what this means, G composite H. That means they're taking H and they're putting it into function G. Now notice what they've given you. They've given you the result of putting H into G. So you put H into G, that gives you F, and they've given you F. So we got to figure out what H is so that we can put it into G. That should give us F. So whatever function I put here, I'm going to put it into this function so that I can get this one. Does everybody understand what this is saying up here? H, composite, H put into G gives you F, and that's what they're giving me as F. Okay? So it's kind of going backwards from what we did on the last page. On the last page, if you would have had this, G composite H, then we actually took H and we put it into G because we knew both of those. I don't know them now. I'm trying to figure them out. Okay? I know the result of putting H into G. All right? So, when you look at this, what would you say is the more basic parent function? Reciprocal, linear, quadratic, absolute value. What would that thing be?
Would it be a reciprocal?
It's a reciprocal, because you got an x in the denominator, right? That's a reciprocal. So if I take, and then if you look at the bottom, by itself, that's a line, right? If you look at it by itself. So if I want to write g of x to be the reciprocal, just keeping the -4, and then over here putting the linear function, -3x minus 4. So now if I take this and I put it into this, will I get this? Okay? So if I were to take this and to put it in this function, would I not end up with this thing here?
You would.
I would, right? Alexis, does that make sense?
Yeah, but
As far as how you get it, that's the hard part.
But isn't there another, isn't there several ways you could do it?
There are a few different answers.
so
It's just
you
you have to
took
do
like
one
the
of them.
bottom.
I took the most basic parent function, okay? And then I looked at this and said, okay, that's a linear function. So if I take the linear function out of this and just write this as a basic reciprocal, okay? Now I wanted to keep my 4 so that it was easy to just plug this in here, okay? So whatever you have for your x here, you need to be able to replace it with what's here, okay? So like when I look at this one, I'm seeing a cube root function, but inside the cube root function is a quadratic, right? So if I can think about taking this quadratic out of it and putting it over here, then I could plug that quadratic into the cube root. So if you
like
think about,
your h would equal to 5x squared minus 1.
yep,
Okay.
and then this is going to be the cube root of x minus 2. So if I take this quadratic out and make it an x, so right here I've got the cube root of x minus 2. that means I need that quadratic over here so that I can plug this into this function and get this. Does that make sense? And so here's another more basic, this is another reciprocal function. And here's a linear function that's been put into a reciprocal. So if I take the linear out and put an x there, then I would have a 1 over x here plus 6. And then the linear function that needs plugged into that is 3x minus 5. Okay, so take this, put it in here, and now it looks like this if you do that.
I thought that was gonna be way more complicated than it is.
What's that?
I thought it was gonna be more complicated.
Yeah,
than
and
it is.
once you figure these out, they're not bad. But sometimes it's hard for people to wrap it around their brain, you know, how to undo those, okay? So, but once you figure it out, they're really a lot easier than the domain problems on the previous page. The hardest part on this lesson is domain, okay? Whenever you have an x in the denominator or a even-numbered root, yes.
Just hypothetically,
Uh-huh.
on number 19,
Uh-huh.
could the, like, h of x, could that just be 5x squared? And then there'd be like an x.
And then put an x minus 1, yeah, yep, theoretically you could do that. You're kind of playing, Hawks typically, I don't know if they have all those answers available. I know they have this one, where you pull out the one function and turn it into the most basic one over here you can,
Okay.
okay?
that makes sense.
But yes, theoretically, that's true, okay? All right, any other questions? All right, you guys got the rest of the time to work?